Well, hi and welcome to my shop. Thanks for joining myself and Shadow. We're getting ready to work on a radio. A radio I had in my shop a couple of years ago. I shotgunned the capacitors in it, which means I just cut out all the bad ones and replaced them. And after that, the radio never worked right. It squeals. I call this radio the Squealer. There it is there. And I couldn't overcome the squealing problem with it. And I went on to other projects, and this is sat. Actually, it sits in my office looking at me every night. Oh my gosh, it's a cat city in here today. So I brought that radio into my shop once or twice and fiddled with it to try to eliminate the squealing sound. Yes, the squealing sound. That wasn't much of a squeal. Yeah. Well, I still want to go outside, but you can't go outside. It's too cold. It's too cold. That's right. I know. I'm starting a video here. I've got to get back to work. All right, we got another cat. So either in changing the capacitors, I either made an error, which is quite likely, connected something wrong, introduced a short circuit, or something of that sort. So this is a nice little radio. Weighs a lot, believe it or not. Here's the schematic for it, and I just want to show you down here that in fact this radio was manufactured under 3 different manufacturing names: Rogers, Majestic, and Deforest. The one I have is the Deforest version. And then there's 3 different models, which I'm guessing they're all exactly the same across here, just with different manufacturers' names on it, I think. Mine is this one, the 10DA517, and I know that from looking carefully at the poor cat. I want to go out. Yeah. There's something else. I can't recall this now, but I see right on here I've written 12Q7, where the schematic says 12B6MT. MT is metal tube, by the way. And if we look down here, there it is, 12. So I can't remember why I wrote this. Maybe there's a different tube in this radio. So let's take a look at it. And it's a nice looking little cute little radio for sure. Here. Yes, this has been staring at me every night. I look over at it and I know it's laughing at me. There's been very few radios. That's quite a few lights. Very few radios that have essentially defeated me. This is one of them. It's defeated me to this point. Just put that over here. 1, 2, 3, 4, 5 tubes. Transformer. Oh, that's a little surprising. Oh yeah, there's a transformer. I thought this was a 5-tube radio, a live chassis type radio, or a hot chassis radio. I don't think it is. That's right, it's slug tuned. There's a slug going through this coil. You can see the motion of the slug coming out. That's very unusual. Oh boy. You know what? I know what the problem is. The problem is there's no food upstairs. That last meow was a, hey, pay some attention to me. Okay, Peanut, should we go get you some food? What do you say? He's wondering what Shadow's up to, because she's right here. So my 2 cats, they really like each other. They spend lots of time playing. They run around the house together. They sleep together. What are they going to do here? Okay, I gotta go feed them. I can't not do this. Okay, well, the cat didn't really want any food. Turns out what he really wants me, for crying out loud. He just wants to be up here with me. He's got a new perspective from this height. He's checking everything out in here. Oh, Peanuts. It's a long winter, Peanut. It's a long time here. Here. For the people. There, a little bit of purring, I hope. Oh, ready to go down. That's good. That's a good sign. Going down. Going out. Okay, he's happy now. See the tail? Tail up. Well, it's not up 100%. Tail up with a crook on the end. That's a happy cat. Okay, let's get focused here. I'm having a lot of trouble getting focused this morning. Nothing doing that. So what about this weird tube thing now? Why do I have a... Oh, there's a handwritten note right there. Which says... I'd say it says CHECKS with the letter S. Checks S. No idea what that might mean. So, why would I be writing down a different tube type here? Is that because this is a 12Q7? So that's why I wrote that down. So probably a 12Q7 is a replacement. I'm going to check that before we go any further. The other thing too, and this was a big issue with this radio, for instance there's a 12K7MT, and I believe this is the 12K7 here, but that's a glass tube. There's no metal tubes in this radio, and this thing says MT, 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 3 metal tubes. And could that be the cause of the oscillations that when I plug this in and turn it on we're probably going to hear? In fact, we should really do that right now. Eh? Let's hear what this thing sounds like. Maybe maybe like a few other things, it's just kind of fixed itself in the meantime. So that cardboard is to protect the radio. Oh, put a resistor here. Kind of an awkward spot. What prompted me to put it in like that? Ah. There was something wrong with the volume control on this radio. And this was my attempt to bypass the problem. So I'm vaguely remembering. It's like the... Oh, there we go. It's off. Let's see. So you can see the dim lights here. I'm going to apply power through the dim lights. They shouldn't come on. The switch is off. Nothing should happen. Let's see. Son of a gun. So the switch does not appear to be working. So let's turn the power off. Let's turn the power on properly. Occasionally these switches fail into a high resistance mode, maybe 4 or 5 ohms in them. On. Tubes are lighting up. I call it the squealer for a reason. So I better close my door for this. A little tiny squealer. Where's the squeal? So that's a very slow squeal. Of course, that's motorboating. There's the squeal. Seems like a feedback or oscillation in the audio section, maybe. Sounds like a laser gunner. I should get my guitar in here and play to it. Turned it into a drum machine. A lousy drum machine. Well, it's still doing what it did. So when I touch the audio grid, audio tube grid, all these tubes have their grids and caps on the top. So we can start right at the first tube. Now I'm not grounded, okay, and this is not 100% safe to do, but I'm taking care of myself here. Now, hear how slow it came back when I touched this? That's a hint to me that there's something going on in the audio section. The fact that the volume control affects it too. The fact that I have this resistor here that I installed for reasons I can't remember now. All suspicious things at this point. Fun, lots of fun. Okay, audio circuits, let's start there. Just sitting here thinking about it. Let's start with the audio circuits. We've got a speaker with a little speaker, but it has a field coil. It has a hum coil. Okay, so as I've learned in the last radio, the hum coil built into the speaker is to compensate for the hum that exists in the field coil. There's no question the field coil has a heavy hum in it. It's part of the filtering of the power supply. So there's a little hum coil here, voice coil. Looks like a ground indication, something to keep in mind. One side of the speaker voice coil circuit is grounded. I'm sure this means to the chassis. It's just something to keep in mind. So what else is going on in the audio here that might... So is there any feedback? No, there's no feedback coming from out here anyway, from the far side of the transformer. Looks like there's no feedback in this radio. Feedback is used to reduce harmonic or reduce distortion. It's very, very common. Maybe not so common in a radio of this age. So if the feedback is truly through the audio, then somehow what's coming out here is getting back into here and coming through again. So usually there are capacitors of a significant size intended to catch any signal that's trying to go back and drown it out. So for instance, let's see, so you could have, for instance, a filter capacitor does that to a large degree. Pretty sure. Come along this line, looking for a capacitor to quiet it. I don't see anything. It's a little odd. Really? So this 10 is it. well, you know, maybe the power supply. Did I do the power supply capacitors in here? Yes, I did. There's one here, one here. Is there any? Oh, this is really gonna. Wow. Okay, so I really got to think back now. So there's a capacitor hanging open here, and this is on purpose. But I can't remember what purpose it was at this point. Just too much time has gone by. Just a sec here. There we go. So we'll have to investigate this capacitor again. But I did a 100% job on this, I thought, in terms of replacing all the bad capacitors. Just looking for any cold, obvious cold. There's a big one here. Seems pretty good. Something a little funny in there. So here's the resistor I added on. So this is the terminal of the volume control. You can't quite see it there. That goes to the chassis. So the incoming signal from the radio is going to come in here onto this wire. And then I've got a fixed resistor across it. It was either because the volume control was hit and miss something terrible, I wanted to settle it down. I put in this resistor just to settle it down. Can't remember exactly. Could be somebody else's work in here also, I think. I don't recognize this little deal here. That capacitor that goes to the chassis that never made the connection properly. So it's not doing its job. Checking them thoroughly here just to be sure I'm not being fooled. Okay, so what about this one? Why is this one like this? And look at that solder job in there. That's a heck of a schmozzle in there. That's a ground point. This is a ground point. So this is a capacitor to ground. Just hang in here. I don't even see any. Maybe this is a connection point for feeding in a signal, and I tack this capacitor in. Let's see, where are we here? So, well, that doesn't make a lot of sense. Oh, wow. Because this is the ground. So why would I? Why would I? Well, that's going to be really tricky to figure out where this should go, because it's just on a ground terminal. That doesn't identify much for me at all. The wire's got no solder on it on the end here, as if it never ever got connected anywhere. I have to watch back my old videos from years ago to find out what the heck was I doing here. Or I have to go through the circuit diagram and verify every capacitor as being connected correctly. I'd rather start off with the assumption that I did the wiring correctly, and that the problem is really related to something else. like to start out that way. They're supposed to be metal-clad tubes. Usually pin 1 is the grounded pin on a metal-clad tube. You can see it right there. Same thing here. A lot of these tubes have internal shielding, so this one here would also be so this one, pin 1. Yep, goes to ground also. I've hunted for metal tubes for this radio and couldn't find them, but I have a much more extensive tube collection now. So I really think I need to try to find metal tubes to put into this radio before going any further with it. To prove that it's not the unshielded nature of the tubes. My manual shielding here. This guy anyway. Let's start with this guy. And that is the first tube. 12, oh my gosh, 12A8. 12A8 metal. Wow, I don't think I got that. But I'm going to go look. We shall see. Well, my memory's coming back now. So I did my hunt for a 12A8. No, I don't have one. I do not have one. I certainly don't have a metal one. Whoops, I may have another non-metal one, but here's what I'm going to try. Okay, I have this tube shield. It's big enough to go around this rather fat tube. A ground lead to ground it. So I'm going to turn on the radio, slide this on, try not to touch the grid cap here. See what happens, apply the ground, see what happens. Basically, we're going to see what happens. Here we go. Here we go. Really not the kind of thing I would think a tube shield is going to solve, but got to try stuff. Oh, there we go. Another thing I noticed, by the way, is there's a paper capacitor right under here I missed. It's so filthy dirty. So maybe I should change that one too. Okay, here we go. Around it. Well, okay, so that didn't do anything. That's my conclusion there. Maybe trying to get a metal tube isn't going to be the solution here. You got to assume somebody put in these glass tubes at some point, or this isn't really the correct schematic exactly, and the radio worked. I got to change this capacitor. I really do need to do that. That's what's next. Yeah, I'm having some trouble seeing the wiring on that capacitor. Now, the one wire was easy. I've already cut it. There it is, cut. It's the other one back under here. There it is. Very hard to get to spot here. To pull out this tube, 12A8, and get access under there. .05. Okay, I'll stick another .05 in there. Okay, let's give this another go. Now I really doubt replacing this has had any real effect on the radio, but let's see. We will soon know. Pretty quiet. Ah! It's very different. Totally different. Doesn't sound right at all. That's the top of the IF tube. Made a big difference in the way this radio operates. It really made a big difference. What is it about this capacitor? I wonder if there was a short on it. Let's not be counting our chickens too quick here. So this capacitor is right across the tuning coil. That's not too bad. That's not bad at all. Just don't turn it up so high. Let me put an antenna on here. Something that resembles an antenna anyway. Pull up a bit. That doesn't sound too good. That sounds pretty bad. Out of the pan and into the fire here with what I just did. Maybe I boot this up. Oh! Yeah, something going on here. Oh, something really wrong with this radio. Maybe there's two things or more wrong with this radio. Maybe that's what's really throwing me off. So far, no good. Okay, so I've decided what might help me is just to get more information about this radio just by doing some kind of random test, if you like. So I've got my signal tracer here. We're going to listen to the signal going through the radio as best we can, see what we get here. So next step is to feed in a controlled signal into the radio. See if we can get anything to come out. Anything, get all the way through from the antenna inward. Okay, I got a fairly strong signal. What's burning? Okay, so I think it's just these very hot tubes over here. I think it's just these two tubes are really hot, and I think that's where the heat is coming from. Okay. The aroma of old radio, that's what I got here. Okay, so we have the output coming from the signal generator, only connected via one wire at this point, just to start off with. I have a fairly strong signal coming over 400 hertz modulation, and the frequency is 11, up around here. I'd say there's nothing there. Let's full power. Oh, that did something. I just blew something up. What happened to it? Cold. This joint here. Is it? Doesn't look very good. That's an original connection there. It's got to be soldered solid there. Something else. It's the antenna wire coming from the antenna. Which way is normal? Maybe I didn't solder the connection down under there properly. I haven't attached anything. What is this? So this part here is a capacitor, a adjustable trimmer capacitor, and that's the connection to the lead there, and that comes up to the coil there. And the wire is attached here. This is probably a piece of metal that goes in and comes out again here. This is probably all one piece. Yeah, you can see the whole thing moving. So they have a terminal for the wire, so they can make this up in the factory at a bench and deliver it to the guys building the radios with this connection already made, and then the guys building the radios attached to here, which they've done. Okay, fine. Now but it's this one back here that's gone. It looks weird. Oh, yeah, let's just look at the wire. So you see how they've done it? A very light wire straight to that terminal. So that's what we want to try to see on the other side, if we can. See the light wire. Should be coming to this terminal here that I'm pointing at. And I think I can just see the wire heading that way. There it is there. Oop. Pretty safe to assume it's connected to this terminal fine. What's going on this terminal is kind of weird though. Especially, what? Oh! What's this down here? What is that? Ooh. That's a wire going up the back of the radio here. It's this black wire right in here. It's coming. You know what that is? That's the, I don't know what that is. Do you know what it is? I don't know. Black wire here, for sure. Comes up. Okay, so the black wire there. That's it. Let me move the wire down here. Wow. Okay, so is that a little piece of wire in there hanging on for dear life? It's not behaving like wire. It's behaving like cloth. This is broken off. This is broken off. Really? How the heck would that ever happen? There we go. There we go. That's going to do it. You know what? That's, if I can solder that right there, we're golden. Now, where's the official solder? Where's my official solder? Try to be as conscious as I can when I set the solder down so I don't end up like this. Okay, we'll just use this other stuff. I got some super thin stuff I don't like to use very much. Oh, there it is. Way over there. That's better. I'm all happy now. Right in there. Big fat soldering iron in there. good. Quickly to the close-up. I got it. I mean, it's ugly, but I got it in there. Do I dare wiggle that? I have to wiggle that wire. I don't think I can wiggle it. It's kind of out of reach. There's a little bit of a wiggle. It looks alright. Well, let's give it a test. We'll see now, because it's lunchtime here. So I remember now that the volume control was intermittent, and I put this resistor on to just stop the intermittentness of it so I could continue troubleshooting. That's what I remember doing. Volume down, no antenna, no tube. Jim, no tube. Tube. Here we go again. Okay, we're doing this with dim bulbs in the circuit. Let's be optimistic, and we'll not. I was going to say we'll put on an antenna, but we won't. Ah, I hear it. It's ticking. Tell me that didn't make any difference. Come on. Attaching that wire made no difference? No antenna effect. I put my finger on it. It sounds like a radio. So all I'm doing is by putting my finger there, I'm sort of rebalancing the circuit, and its fluttering just changes. Well, let's stop the wonkiness here. Could it be alignment issues at this point? You know what? Let me look again here. Okay, so the antenna is kind of missing from the diagram a little bit. It looks like it's just looking for a wire antenna. I suddenly jumped to thinking that maybe there's a coil antenna. But I don't believe there is. A coil here and a coil here. Both tuning. Do those coils share this form? Yeah, because these are the two trimmers. One is for the one will be for the local oscillator. The squealer, still squealing. Okay, another possibility is the radio's IF is tuned up so sharply. That's a stupid idea. This putt-putt is almost always from trouble on the AVC line. Let's look at that next. Let's see if I can see what I can find on that. Oh boy. Okay, yeah, it was just down the street where some city crews are digging up our water main again for the third or fourth time since I've lived here, always down in the very same area. Okay, what I'm going to try, and this is a stupid thing to try, but let's try it. Isn't that interesting? You know, this has to be a big hint on what the problem is. So what I thought was, I'll measure the AVC voltage here with the meter, as invalid as that might be, and just see if it's, oh, I'm not going to be able to, this, yeah, digital meter, sure. No, I'm just killing it. You see it's at 1.4 for a fraction of a second. They're probably in minus 4 or 5 volts on here, and I just knocked it out by, see, that sounds almost like a radio when I touch the top of this tube. That's not going to do any good. There! Yeah, bogus test. So what I was thinking I would see, first of all, I was thinking I'd have a pointer. There's no pointer there. I thought I'd see it as the radio chugged. I'd see the voltage chugging with it, and it's AVC. Oh, okay, AVC problem. I think we really got to go on the basis at this point. It's a problem in the AVC circuit of some sort, somewhere in there. Squeak's still there. What is that? I don't know if that's like running your finger around the rim of a glass and making that sound. Is that what that is? I think it is. I think it's just... Oh, crying out loud. I think it is. I think it's just the... it's just something rubbing and making that sound. Okay. You name it. What was I doing? I was doing something. I turned this right side up for a reason. A reason I can no longer remember. Oh yeah, this thing here was doing something for me. Tube? That's the rectifier tube there, I think, and this is the 35. Let me check on here. (35L6). So this is the output tube. This is the rectifier tube. Something more going on underneath, I think. Wow! Lunchtime. Okay, I just finished a pile of research into this tube here. Here it says 12B6MT metal tube. What's in there is a 12Q7 glass tube. I had to look a long time on the internet to find any reasonable reference to this 12B6 tube. This must be extremely rare. And sure enough, I found one reference on just radios, in fact, that showed a 12Q7 was an appropriate replacement, or suggested it anyway, for a 12B6. So maybe this is all just fine, except what it says is if you're going to put in a 12Q7, it's a glass tube, you need to put a shield on it. We're back to the unshielded tube thing. Maybe I had the right idea with the shield, I just didn't try it on the right tube. Get my shields back here. So we're gonna try it on here. Oh boy, that's a snug fit. So we know what the radio sounds like without it. I'll have to install it and then turn the radio on. (12Q7), no doubt about it. Far from perfect, but it should be, if it's going to make a difference, this should do it. Okay, I'll put the clip lead on here. Okay, let's give it a go. So numerous times I've reached the point where I'm pretty sure I found out what's miswired or not done right in the radio, only to determine shortly afterwards that no, actually everything's okay. Okay, I'm going to fill some more here. Do something I'm not really supposed to do. The radio in the condition it's in. I'm just going to fill around with these. Another possibility with a radio like this is you can get these things peaked up so hot that they oscillate, they resonate. They oscillate, I guess is the right word. Well, I certainly wrecked the oscillation pretty easy. Let's just keep fiddling around here. There's a wire to pretend there's an antenna. Not much of a wire. I just swear it's because of the AVC line. Maybe I should just go ahead and pile some more capacitance onto the AVC line. Why don't I try that? No, it's still doing things. Okay, if they're doing that, I'm going to increase that capacitance to ground. Whoops. certainly changed its behavior. Same thing. Yeah, it's very much like there isn't enough. There isn't enough. Point one's pretty good. That's full blast too. That's not so good. You really got me on this one. Not sure why that just happened. Why would that go quiet? So this is the positive side of a great big capacitor. Why would that do? Why would it go quiet? Still a little bit of that noise there. Okay, I'm going to connect up the outdoor antenna, at least the center conductor. If you want to think of it that way, it's a coax cable lead out to a wire. That's the way that's working. Wow. Okay. Just, I was going to say the mystery deepens. I don't know if that's quite the way to phrase it now. So I'm adding a very small capacitor to the positive side of this large filter capacitor. Let's take a look at the schematic and see where this exactly is. The two of them right there. One of these, one is a 10 and one is a 20. Well, where's the originals? So I believe the originals were large capacitors in here that I've removed and replaced with these. So we can't look at the originals at this point. Excuse me, now usually I'm pretty careful about making sure I get the polarity right for capacitors like this. That means there's a good chance I got it wrong. Well, how am I going to sort out which is which here? Okay, wow, look at that. Oh my gosh. It's been a long day staring at this. My impression now is that this capacitor I put in is incorrectly installed. Pretty sure I was just duplicating what was there already, but maybe not. Maybe I was trying to get a little fancy or something, and I thought this was, I don't know, looks like this connection should really be here. Doesn't make sense where this is connected, and looks like it should be connected. This would be a suitable point. It's a big deal moving a big capacitor like this. I'm a nervous guy. Let me just check it again. Okay, I'm thoroughly convinced that this lead should be to chassis ground. It's here because I think I put it there because I thought that was chassis ground. Mistake on my part. This whole thing's been about, I think. Wow, I don't know if that come across on the microphone, my stomach growling there. Okay. But I can't stop because I'm so close. That's terrible. That's just terrible what I did there. Let's do that again. Sometimes you just the angle you're looking at, you don't really see what's happening, or you think you see what's happening when you don't. Go. I'll do a quick test to prove that this capacitor is negative lead. And it's connected to the chassis. That's pretty convincing. We're ready for a test. A big test. Big test. For a little radio. I should have been more suspicious of my own work. I think the thing is I did too much of it all at once. Didn't know what part to be suspicious of. And I'm pretty sure I just installed those, well, I won't say it anymore. I'm not pretty sure of any of them. Okay, no need to delay. Volume down to about there. Gonna be on restricted power. Here we go. Yeehaw. Okay, so the dim lights worked fine. Just got a glimpse of them up at the top of the screen there. Low volume. Low volume. Jeepers creepers. Well, I think we're away to the races. Remember I mucked up the IFs. Yeah. Man alive. Okay, I hate to admit how many hours of work that is, but you can see from the clock, I wasn't in here the whole time today, but oh boy, oh boy. But you know what? I stuck with it and I got it. And we'll tune this radio up and away it goes.